Hey, this is Mr. Ward, and this is a key to PreAlgebra Do Now 22.1. That's week 22, day 1. Welcome back from break, and our first question is a multi-select. That's what these little squares mean instead of circles, and that's why I wrote prick all that apply. Which of these are in scientific notation format? So there's a key to scientific notation format. If you remember, there's a coefficient, and it's going to be a some number. So we're going to call this the coefficient times 10 to some power. Now, the power needs to be an integer. It can't be a fraction in this case. But this coefficient needs to be between 1.0, okay, and 10, but not 10. So it can be anything up to 10. So it needs to have, basically, the first digit needs to be 1 to 9. So first digit is 1 to 9. And it is only one digit to the left of the decimal place. So only one digit. Okay, so that tells us that this one is right out. And the reason it's right out is it has 2 digits. That's a 55. That's more than 9, 9.999. It's definitely more than 10. This one works. 5.5, that works. 10.1 is more than you can allow for that. 1.01 and 3.982 are just fine. So these 3 are in scientific notation format. Are these mathematically problematic? Absolutely not. They're totally fine. These are mathematically completely legitimate expressions. They're just not in scientific notation format, and that's what I'm asking about. Okay. What is the place value of the first 5 in 55 times 10 to the 8th? Well, the first 5 in this is defined, so that's 10 times this, okay? So 10 times, that's a 55, so 10 times 10 to the 8th would be 10 times 100 million. 10 to the 8th is a billion. So if we were to, it would be helpful to rearrange this into scientific notation format. If we were to put this in scientific notation format, which would be 5.5, we would have pinned down what the place value is, because what we're doing, I'm going to do this in 2 steps. What we're doing is we're taking 55 and we're making it 5.5 times 10. Okay, and then over here we still have, of course, our 10 to the 8th. So all I'm doing is, and I'm just showing what's behind the curtain. What I'm doing is I'm moving a factor of 10 out of 5.5, and I'm going to move it into 10 to the 8th. So 5.5 is going to end up being times 10 to the 8th. Well, that's 10 to the 1st times 10 to the 8th, so that's 10 to the 8, 1 plus 8, or 10 to the 9th power. And so the 9th power, 10 to the 9th power, is 1 billion. So billions place is what this is. This 10 to the 9th is telling us what this sort of pretend ones place is in the coefficient. It's telling us that it is 5.5. This is 5 billion right here, and that's 500 million. So this is 5,500,000,000 is what this is saying. So the first 5 is in the billions place. All right, now which one of these would be an equivalent expression to 47 times 10 to the 3rd? Well, the first one, 4.7 times 10, that's the same as 47 times 10 to the 3rd. So this is the same as 47 times 10 to the 3rd, so that's good. How about this next one, 4.7 times 10 to the 3rd? Well, the 10 to the 3rd didn't end up changing. We just changed 47 to 4.7. So we made this 10 times smaller, but this didn't change at all. So what we've overall done is made the entire expression 10 times smaller. So it's not the same thing. 4,700. Well, if this is in the thousands, then what really is in the thousands is the 7. The ones placed digit in the coefficient is defined by what this power is. That's the place value. So 7 is in the thousands, but here 7 is in the hundreds. So that's not it either. But this one has 7 in the thousands. So that is legit. Okay, and then I've got 4.7 times 10 to the fourth. Well, that's what would happen if I took this 10 and I multiplied it times 10 to the third. That would become 10 to the fourth. And the 4.7 is preserved. And that all we're doing is we're making 47 10 times smaller and 10 to the third 10 times bigger. So we're preserving that 10 timesness. So this one is totally legit. How about this one? This one might be a little tricky. Well, here we're saying that the 0 is in the hundreds place. Well, if the 0 is in the hundreds place, because 10 to the second is 100, the 7 is in the thousands place. And that has been consistent for all of the ones that we've picked, okay? And then the 4 will be in the 10,000s place. So this looks good. Let's look at it another way. 47 going to 470, that's making 47 10 times bigger. If we make 47 10 times bigger, we have to account for that by making 10 to the third 10 times smaller. Is 10 to the second 10 times smaller than 10 to the third? Absolutely it is. So that is a legit equivalent expression. Okay, what is the place value of the 5 in 3.75 times 10 to the third? Well, you could work out that the 3 is in the thousands place, so you could just sort of work backwards. So 3 is in thousands place, 7 is in the hundreds place, so 5 needs to be in the tens place. So that's a way you could approach that, and that's absolutely right. There's another way you could approach that. We could make this 100 times bigger, 3, 7, 5, and make the 10 to the third 100 times smaller. And what this will tell us is what's the place value of the ones place in the coefficient. The place value for the ones place is 10 to the first, which is 10. So that's the same dang thing. All right, I hope that was helpful to you, and I will stop the video.